Examples 5 and 6, we're going to be looking at other techniques to integrate when you have more complicated problems like polynomials, these rational functions. So the first one, just like the example says, is we're going to use long division. So just a little recap from pre-calculus. If your divisor is a binomial to the first degree, x plus 1, we could use synthetic division. And again, this is going to be the divisor that we're going to use. And then we just focus on the coefficients for each term. So that would be 1, 3, -1, and -3. And we bring the first coefficient down. We multiply it to our divisor. That gives us -1. We do an addition. And we just repeat the pattern. 2 times -1 is -2. That gives me -3. -3 times -1 is +3. And we get a 0. So we know that there is a x plus 1 factor in the polynomial in the numerator, right? So now that we've canceled out an x plus 1, we could rewrite this as x squared plus 2x minus 3. And another thing to remember, since you technically factor out an x plus 1 from the numerator, now the leading coefficient should be 1 degree less. So x cubed is now x squared, and you just follow along, okay? And these are going to be the new coefficients for the term. And you guys see now that this is going to be easy to integrate. And the 2 cancels out. And don't forget your c. Okay, so that's pretty much it. Again, you could use synthetic division because the denominator is x plus 1 is a binomial to the first degree. So you could do that, or else you would have to do the actual long division. Okay, for this one, again, we're trying to simplify this. We cannot really do u substitution. It doesn't work out. I see the difference of squares for x squared minus 4, but that gives me x squared minus 2 times x squared plus 2, so it doesn't really cancel this out here, right? But again, we just use long division. So I'm dividing x squared minus 0. Don't forget, you have to put your the term. Like if you're missing x squared and you're missing the x value, just make sure you put a 0 for that. And now I ask myself, x squared plus 1, what can I multiply this by to cancel one of these out? And the answer is just going to be 1. If I multiply x squared plus 1, I end up getting x squared plus 1. And don't forget that you have to subtract, right? So if I subtract, this cancels out, and this becomes -1, so that gives me -5. So x squared minus 4 divided by x squared plus 1 becomes 1 minus just the remainder, -5 over x squared plus 1. Okay, and again, these are long division. If you're not really sure what I'm doing here, you probably want to search a long division video just to get a little recap. All right, so now I have this integral. I could break it up, right? The integral of 1 is just going to be x. And this one here, I could take out the 5, and I'm just going to be left with 1 plus x squared plus 1 dx. And just a little recap. The derivative of the tan inverse function is equal to 1 over x squared plus 1. So if we're doing the antiderivative, we're going to be left with the tan inverse of x, and that would be your answer. Okay. So again, when you see this kind of pattern, when you see 1 over x squared plus 1, you already know that we're dealing with the tan inverse. Okay, now if you have something like this where you have a quadratic in the denominator, but sometimes it doesn't factor out completely. This one actually does. So it's really not completely in the square because it just factors out. But let's go ahead and take a look at this. So how can I factor out the denominator, right? You try your first maybe x method, right? What two numbers multiply to AC and add to B? So what two numbers multiply to 16 and add to negative 8? This one's straightforward. I have 4 times 4. That adds to 16 and that would add to 8. But because it's negative, we want to make sure we have negative 4. So these are going to be my two factors. X minus 4 times x minus 4. And now this becomes a lot easier. I do use substitution for x minus 4. du is equal to dx. And I'm left with u squared dx. Bring that to the numerator. And I'm going to go ahead and make sure that you remember du is equal to dx. And now I could integrate. And this should give me negative 5 u to the negative 1 plus c. Again, right, when I integrate, I'm adding 1, and then I'm going to divide by that negative 1. So that's why we have a negative 5 here. And don't forget to change u back to what it is, x in terms of x. And that would be the integral. Okay, for this one, you could also do this little trick here, but obviously this is a little bit harder, right? What two numbers multiply to 2 and add to 2? That one's a little tricky. What two numbers multiply to 2 and add to 2? Well, you're first probably thinking, well, 2 times 1, but that doesn't add to 2. 1 times 1 doesn't multiply to 2. So that's not going to work out. And this is when we use the technique of completing the square. So what you essentially do is you ask yourself, what number can I add here so that I could get the same factors, right? And the whole idea you have of the binomial is going to be squared. And the technique that you're going to do is you're going to say, what c can I add here so that I get a perfect square trinomial and my two factors would be the same. And the technique is you say c is equal to b over 2 squared, right? So you get your b term, and that's going to be the middle term. Remember, any quadratic, we're going to express it in this way. So our middle term, or the coefficient for the x, would be our b. In this case, is 2. 2 over 2 squared. That's just 1 squared, which is 1. So what I'm going to do is I'm going to add 1 here. But remember, you can't just add a 1 and expect things to be the same. You have to balance this out. So by adding a 1, I'm going to subtract the 1, and it's as if I added nothing, right? But now I know that this is a perfect square trinomial. What two numbers multiply to 1 and add to 2? This becomes x plus 1 squared, and I just balance this out. I end up getting a plus 1. And again, now I'm seeing this pattern here. I'm already thinking of the tan inverse. But first I have to do u substitution. U is equal to x plus 1. So du is equal to dx. And when I do this, I could factor out the 3, by the way. I'm going to be left with u squared plus 1 du. And again, I already know that this is the integral of 1 over u squared plus 1 is just going to be the tan inverse. So in this case, my answer is going to be 3 times the tan inverse of u plus c. And remember, u is equal to x plus 1. All right, so those are the techniques. And just a faster way, I did the completing the square technique so you guys could see how it works. But technically, we already have a 1 here, right? Technically, the 2 can be broken up into 1 plus 1, and this is just x plus 1 squared plus 1, okay? But again, sometimes it's not that easy, so this would be the complete way of doing it. Just remember, c is equal to b over 2 squared, and then to balance it out, make sure that you do the opposite. If you added 1, make sure you subtract 1. And there's going to be another part where you have to factor out, in order to complete the square, you need to have your coefficient, the leading coefficient needs to be 1. So sometimes when you do this, and if it's in parentheses, remember, whatever you add here, let's say I added a whatever, right, a 1 to balance it out. If I add a 1, in reality, what I did was I actually added a negative 1 to the whole equation. So remember, this negative 1 here makes it as if I added a negative 1. So I would be adding a 1 because this technically would be considered me adding a negative 1. So I have to balance that out with a plus 1. All right, so just look out for that when you have to factor out a negative when you're trying to complete the square.